Okay, this is problem set 17. And luckily these homeworks aren't too terribly long. I think this one here only has 9 questions, and then the next one only has about 6. Oops. So let's go ahead and take a look at number 1 here. So we've got f of x is this here. We want to know on what intervals is it concave upward, and on what intervals is it concave downward. So in order to figure out concavity, we have to take the first and second derivative, because our second derivative is what tells us whether or not a function is concave upward or downward at any given point. So if we take our first derivative, that's going to become 6x squared minus 48x plus 16. Then taking my second derivative, I've got 12x minus 48. Okay, so what's important here is both our critical numbers for this, so whenever our first derivative equals 0 and whenever our second derivative equals 0. Our second derivative tells us when that equals 0, that tells us our inflection points. And if anybody's unclear as to what an inflection point is, say I've got a graph that looks like this, right? So here it's obviously concave downward, here it's obviously concave upward, but at some point it has to switch in there. And so right here, for example, would likely be one of those points. I forgot what they're called. An inflection point. Right here would be an inflection point where all the way up to this point it's concave downward, and then at this point exactly it switches to being concave upward. And you probably have another one on this side and so on. So that's all our inflection points are. And so we need to know those in order to know our intervals of concavity. So first, we'll set this first one equal to 0. This will be fun. I'm going to factor out a 2 just to make it a little easier to minus 24x plus 8. Okay. I'm not sure if we can factor this or how we can factor this. Okay. So I've got negative 24 is my b, and a positive 24 is this. So I don't think we can factor that. So let's go ahead and use our quadratic formula. So x equals my negative b plus or minus this here over 2a. So in this case, negative b is just 24 plus or minus, what is 24 squared? 576 minus 4 times a times c, so it's going to be 4 times 24. 24 times 4 is 96. All over 2a, so it's going to be 6. So that becomes this here. Oops. Oh, that's not a pretty 0. So that's going to be a 480, I believe, over 6. Let's see. How can I factor 480? Yeah, I don't think there's any more there. So let's see, I can factor out 2 4s. So it's going to be same as 24 plus or minus 4 times the square root of 30 over 6. And I can go ahead and divide that. So it's going to be 4 plus or minus 2/3 square root of 30. And that's just 24 divided by 6 and then 4 divided by 6. Obviously, it's just another way I can rewrite that. So this equals 0 at x equals these 2 points. Okay. And honestly, we could try and figure out about how big that's going to be, but I'm just going to figure out, I'm just going to use the calculator to see what those look like. Okay, so for minus this, oops. So 4 minus that is about this, and 4 plus it is about that there. And the only reason that this matters is because I want to be able to easily pick a number that's going to be on those intervals, and so that I can make sure that I've got everything in order. It's not totally necessary, but it's just helpful. This, on the other hand, equals 0, so it's going to be 12x equals 48, x equals 4. So we've got an inflection point at 4. So now take a look at our intervals. I've got negative infinity up to 4 minus this, and then that up to actual 4, and then 4 up to 4 plus this. I guess in this case it didn't super matter because I could tell the order pretty clearly here. But now finding something on this interval is a little easier to do. So now we just plug in something on each interval and test for our concavity. So on here I could plug in a 0. If I plug in a 0 here, that's just going to be 0 minus 48, which is less than 0, which means I have a maximum. It is concave down. Between here, to figure out, to make sure, it's probably still going to be concave down. Oh, I forgot another part of my interval. Oops. Then up to positive infinity. So this is probably going to be concave down, and this is probably going to be concave up, but we always want to double check, because sometimes it's not what you expect. I'm going to plug in a 1, because that should be on this interval, and that's going to be 12 minus 48, which is still less than 0. Okay, so still concave down. And then let's plug in a 5 up here. 5 times 12 is 60. That's greater than 0. So it's concave upwards. And then here I'll plug in an 8, because that's greater than that. 12 times 8 is 96, I think. Which is still greater than 0. Okay, good. Okay, so it is concave upward on this interval. So from 4 all the way to infinity. These are connected, so I can just go from here to here. It's concave downward from negative infinity up to 4. Not inclusive all the way around. Let's go ahead and erase some of this so we've got room for our next problem. Number 2 gives us a different function and asks us pretty similarly to figure out the relative minimums and maximums and then check the concavity. So if g of x equals this, g prime of x equals this, and g double prime of x equals this. And I am going to factor out 3 there, so I get 4 x cubed minus 27. Okay, so this is going to equal 0 whenever this inside part equals 0, which is why I factored that out, because I've just got easier numbers to work with like this. So I want to know when this equals 0, 4x cubed equals 27, x cubed equals 27 divided by 4. So this equals 0 when x equals the cube root 27/4. Notice there's no plus or minus. That's because this isn't a square root. Obviously, cube roots can be negative. And then this equals 0 whenever x equals 0. Okay, so our inflection point is at x equals 0, and our relative extrema is at this point. So it's going to be infinity up to 0, 0 up to the cube root of 27/4, cube root of 27/4, up to infinity. Okay, how big is the cube root of 27/4? Well, it's probably going to be the cube root of 27, which is 3 over the cube root of 4, which is definitely less than 2. So this is going to be between 1 and 3, definitely. But it's definitely bigger than 1. I'm confident in that. Well, maybe not. You know, it should definitely be bigger than 1, which means that I can plug in a 1 in there. So we're going to plug in a -1 for this interval, a 1 for this interval, and we'll plug in a 3 for this because that should be bigger than that. So -1, 1, and 3. Okay, plugging in a -1, I get 36 times -1 squared. -1 squared is just 1, so I get 36, which is greater than 0, which means it's concave up. Plug in a 1, I get 36, which is greater than 0, which is concave up. Plug in a 3, it doesn't matter because it can't be negative, so it's still greater than 0, which is concave up. So it's concave upward the whole way, which is interesting. So that would make me assume that this point is a relative minimum. You can always double check with that first derivative test, but I'm not going to right now. So that tells me there are no maximums, and there's only one minimum, so the rest are D and E, they do not exist, and so this is at the cube root of 27/4. Wow, it's small. Now we just plug that back into the original equation. Okay. Equals this to the 4th. Oh wow, okay. There's a lot happening here. So it's going to be 3 times cube root of this to the 4th minus 81 times the cube root of this. That's probably an ugly number. I would plug that into a calculator. Oh? No. I made this function uglier than I'd hoped. For shame. Anyway, it's concave upward from -infinity to infinity we just found, and downward never. And the relative minimum is at whatever number this is. Let's keep going. Okay, so this first one on this page, we've got number 3. It is just find the first derivative, the second derivative, and intervals of concavity. So we've got to use our quotient rule here. So low d high minus high d low over low low. So our derivative is the low term times the derivative of the high term, which is just 1, minus the high term times the derivative of the low term, which is 2x, over the low squared. Okay. And I'm going to go ahead and I'm not going to distribute this because it looks like I might be able to factor that out later since I see that term exists here. Not for this derivative, but maybe for that second derivative. Oh, there's nothing to distribute. Never mind. I thought there was a power up here. I misread it for a second. But we do want to distribute that. So it's going to be x squared plus 14 minus 2x squared, which is just combine like terms, negative x squared plus 14 over x squared plus 14 squared. Okay, so I see my a is a -1, b is 14, they've got x squared plus 14 to the power of c, c is 2. Now I take that second derivative, same thing, quotient rule, so I take my low times the derivative of my high, which is going to be -2x, minus the high times the derivative of my low, and this is some chain rule here, so it's going to be 2 times the inside because of that power rule, and then times the derivative of the inside, which is 2x, all over low, low. Now, of course, there's a lot happening here. Again, I'm not going to distribute this out. I am going to combine that 2 and that 2x to be a 4x. But I see that I've got this term in both of them. So I'm going to factor that out, actually. So I'm going to factor that out. And then I've got, then I've got a negative 2x times the remaining one there, because this is squared, minus this here, and I factor out this, so it's just the 2 times the 2x, which is a 4x, all over this. So 1 cancels out, and I'm going to move this over for a moment. So now we should probably distribute, I think. So negative 2x cubed minus 28x, then distribute, I'll distribute this first, and that's a negative, so just keep that in mind. So this turns into a plus 4x cubed minus 14 times 4 is 56x, all over this, because we canceled one out, right? And now combine like terms, so it turns into a 2x cubed minus, what is 28 plus 56? It's 84. Oops. Minus 84x. I can factor out an x. Do we do that? I do. I can factor out a 2x. So I'm going to factor out a 2x. And it's going to be x squared minus 42 over this here. And I see my d here is 2. X squared plus e. E is negative 42. X squared plus f. F is 14. And g is 3. Now that we have our derivative and our second derivative, we want to know on what intervals is the function concave upward and downward. So I want that first derivative to equal 0. Remember, it just matters for the numerator, sorry. So this equals 0, squared equals 14. So we have critical points at x is plus or minus the square root of 14. And then we want our second derivative to equal 0. And I see that numerator, I can rewrite it as x plus this, x minus this, because again, that's a perfect difference of squares. Okay. Which means that this second derivative equals 0 whenever, so it equals 0 at x equals 0, x equals negative square root of 42, and x equals positive square root of 42. Okay. Got a lot of inflection points, not very many critical points, but that's okay. So obviously square root of 42 is going to be bigger than square root of 14. So I've got negative infinity up to negative square root of 42, negative square root of 42 up to negative square root of 14, negative square root of 14 up to 0, because that's one of our inflection points. And so on till we are here. And now square root of 42 is less than 7, because square root of 49 would be 7. So I can plug in for this first interval negative 7, for this last one just a 7, right? 14, that's going to be less than a 4. So I could do I could do between a 4 and probably a 6. I'll just do a 4 because 4 is nice and easy. So for here I'll do a negative 4 because that should be between them. If this is less than 4, it's also bigger than 3. So I'll plug in, I'll do negative 3 for that. And 3 for that one. Okay. Now to find out how this goes. So if I plug in a negative 7, that's going to be, this is going to be, well, look at it this way. Yeah, we'll look at it this way. So that's going to be negative. So it's going to be negative. That's going to be 49 minus 42, so that's going to be positive. And that's always going to be positive. So it's a negative times a positive is negative, so it's less than 0. Concave down. This next one, negative 4. 2 times negative 4 is negative. 4 squared 16 minus 42 is also negative. All over a positive. That's going to be, these are going to become positive, so it's greater than 0, and therefore concave upward. Plug in a negative 3, and I get a negative, and a negative, and a positive. And that's going to be greater than 0, so it's concave up. So up, up, up. Okay, plug in a positive 3. This time I get a positive, but this is going to be 9 minus 42. So that's negative over a positive, which those don't cancel, so that's less than 0. Concave down. Plug in a 4. Same deal, it's going to be positive because of 2 times 4. But 16 minus 42 is negative. And then I'm plugging in a 7, so it's positive and positive, so it's all positive. So it's all greater than 0, and therefore concave upward. Okay? Which means that it is concave downward. Here I'm going to do downward in red and upward in blue. So I see that it is concave upward, like we said in blue, from here, so negative square root of 42, up to here, because that's continuous. And then union this interval down here, so positive square root of 42 up to infinity. It's concave downward from negative infinity to this point, union this continuous interval here, 0 up to there. All right, I'm going to go ahead and erase my work over here so we've got room to do number 4. There we go. So number 4, same deal, except they don't care about when it's concave downward, just upward. We're given this function, so g of x equals 2x to the 5th minus 30x cubed. First derivative is going to be a 10x to the 4th minus a 90x squared. Second derivative is going to be 40x minus 40x cubed minus 180x. And I'm going to rewrite this in a factor of 10x squared. Okay, I could rewrite that with my difference of squares. And then I could rewrite this as, I could factor out can I factor out a 4 out of 180? I can, but I can't factor out a 40, I don't think. Because that would be 10x squared minus, would be 90, 45, yeah. Oh, but I can factor out a 5 from both of those. Which means I can factor out a 20. Ah, yeah, that makes sense. Okay, so I'm going to factor out a 20x. So I get 2x squared minus 9. Yeah, 9, not 90. Okay, so I see my, oops, it's a loose square root. I see my first derivative equals 0 when x equals 0, -3, or 3. And I see my second derivative equals 0, also at x equals 0, but then there's this part, so x squared equals 9, x squared equals 9/2, so x equals plus or minus square root of 9/2. So those are my inflection points and my critical points. So let's go ahead and build our interval here. I know that this is going to be less than 3, so that tells me exactly where that's going to be placed. So I've got this. Okay, now let's figure out that concavity. So for this first one, I'm going to plug in a -4, I think. For this next one, oh, square root over 9/2 less than 2. That is the question. I think it is. I'm going to double check that though, just really quick. It is not less than 2. Arg. Let's plug in a 2.5 then. Oops, a -2.5. Pardon. -2.5. And then here I can plug in a -2, but I'm going to do a -1. 1. 2.5. 4. Okay. Okay. Let's go ahead. We've got our -4, so it's going to be a negative, and then -4 squared is a 16. 16 times 2 is 32, minus 9 is a positive. So that's going to be like this. -2.5, that's going to be negative. So I've got a negative times 2.5 times 2.5. 125 times 25 is 625. So it's going to be 6.25, which is going to be about 12.5 minus 9 is positive. So same deal, which means we are concave upward here. Plug in that -1, that gets me a negative. Then 2 minus 9 is also negative. It cancels out, that's greater than 1. So it's concave downward, going to get, okay. So now I've got a positive, and the inside's a negative, because 2 minus 9 is negative, that's less than 0, concave upward. Okay, plug in my 2.5, it's going to be a negative, and the inside's going to be positive. So, oops, I was right, I was drawing the wrong concavities. My math is right, but or my numbers are right rather, because it's all math. When it's less than 0, it's concave down, up, down, up. There we go. Okay. Whoops. Glad I caught that. And then plug in a 4, that's going to be positive and positive. Oops. Which is concave up. Okay, So concave up. Here we don't care where it's concave down really. Remember our critical points were 0, -3, and 3. 0 was also an inflection point though, which is interesting. And it looks like we can't determine it as a maximum or minimum, I don't believe. But I see that I've got a minimum at x equals 3 and a maximum, it looks like, at x equals -3. And then the rest do not exist. Going to go ahead and write on what intervals is concave upward. I see that that is from here to here, union, here to infinity, right? And now all that's left is to plug in those points. So, I put f's instead of g's, but that's okay. So g of -3 is going to be 2 times -3 to the 5th. Wow, that's going to be big. Let's see. 3 to the 5th is 243, so it's going to be -243 times 2 is -486. -486 minus -3 cubed is a -27 times 30 is going to be -810, but that's minus, so it's plus 810. 810 minus 46 is 324. And now for g of 3, it's going to be a positive 273, positive 486, and a -810. So this could be the same thing but negative. Okay. Just a few more questions to go. We're about halfway. All right. And they're just pretty tedious, but they're all pretty much the same thing. So negative. Number 5, same deal. And so I see that f of x equals 4x cubed minus 4x squared minus 80x, which means that my derivative is going to be 12x squared minus 8x minus 80, and my second derivative is going to be 24x minus 8, which I can factor an 8 out of. And this one I can factor a 4 out of. Okay. For where this equals 0, I might have to use that quadratic formula again. Let's see. -2, -60. I forget a little bit how to factor when my a is bigger than 1, but we'll figure it out. So let's see. If this is even factorable, of course. Does not look it. Okay, well, quadratic formula, here I come. So x equals 2 plus or minus 4 minus, but that's a negative, so plus 4 times 20 times 3. That's going to be 80 times 3, which is 240 over 2a, which is 2 plus or minus the square root of 244 over 6. Let's see if we can pull anything out of that radical. Okay, so I've got 244. I know obviously there's 2 and 122. It's 4 and 561. I think, is 61 prime? I think 61 is prime. So I can pull out that 4. So it's going to be 2 plus or minus 2. So the square root of 61 over 6. And yeah, I'll just, it's 1/3 plus or minus 1/3 times the square root of 61. So that equals 0 at x equals 1/3 plus or minus 1/3 times the square root of 61. And this equals 0 at whatever 3x equals 1, or 3x equals 1, x equals 1/3. Those are all pretty close, huh? Okay. So it has an inflection point at x equals 1/3. We can go ahead and answer that. Let's go ahead and get our intervals written. So, is 1/3 minus 1/3 times the square root of 61 negative? I don't think so, but it's probably still going to be right here. I'm going to double check that really quick. Let me just check what that is. I don't know why I put a negative. It's definitely not negative. Or I mean, it might be negative, but like the negative's not going to go in front of that. Okay, yeah. Then I've got, I don't know why I put the plus or minus either, because that's just going to be minus. I keep miswriting that out of habit. This to up to 1/3, then 1/3 up to the plus version. Up to infinity. Okay. This is, okay. Let me 1/3 minus that. So this is about negative 2.27, which means I can figure out concavity with a -3 and a +3. And then, let's see. And I could do a 1 in there and probably a -1. Okay. So let's take a look at those. Let's see, if I plug in a -3, that's going to be 8 times -9 minus 1 is, -9 minus 1 is negative. So it's going to be less than 0, which is a maximum, or concave down. Plug in a -1, it's going to be -3 minus 1, which is -4, less than 0. Plug in a 1, I get 3 minus 1, which is 2, which is greater than 0. And plug in a 3, I get a 9 minus 1, which is 8, which is greater than 0. So it's concave up. And so it's concave downward on this interval here. Okay. It has a relative maximum at this and a relative minimum at this. So it's a little ugly to write. But that's so small too. But it's something like that. And whatever that is when we plug that in, I'm sorry, I really do not feel like plugging that in right now. I was plugging it with a calculator, but it's not like get anything from plugging it in here. Other than just like affirmation that we did it. Let's take a look at number 6 now. Same deal, different function. Gonna erase this part here. Oops. Didn't catch all of it. Okay. So now g of x equals 4x to the 6th minus 12x to the 5th. Take that first derivative, get 24x to the 5th minus 60x to the 4th. And the second derivative, 24 times 5, only 24 times 4 is 96. 96 plus 24 is going to be 120, I think. Minus 240x cubed. Okay. I can go ahead and factor out 12x to the 4th there, and I just get 2x minus 5. And this is, factor that out, nice and easy. Get x minus 2. Okay, so our first derivative equals 0 at x equals 0, and x equals 5/2, right? Because 2x minus 5 equals 0, 2x equals 5, x equals 5/2. This second derivative is going to equal 0 at also x equals 0 and x equals 2. So here I'm going to get negative infinity up to 0, 0 up to 2, 2 up to 5/2, 5/2 up to infinity. Okay. Go ahead and figure out what I want to plug in here. This is 2, this is 2.5. Since 2.5 is a critical point, I could technically plug that in, but that's not included in that interval. We'll do 2.25, I guess, because that should be right in there. And then just do a 3. Okay, so if I plug in a -1 into my second derivative up here, that's going to be a negative on the outside and a negative on the inside, which is a positive, which is greater than 0. It's concave up. Plug in a 1, and I've got a positive and a negative, less than 0. Concave down. Plug in my 2.25, that's going to be positive and positive. And plug in my 3, which is positive and positive. Okay. So this graph has inflection points at x equals 0 and x equals 2. It has apparently a relative minimum at x equals 5/2, and it has no others. And it has no maximums that we can see. Okay. It says g of x is concave upward on what interval? So that's going to be here and here. So it's going to be from negative infinity up to 0, union 2 up to infinity. If I did that right, that doesn't feel perfectly right. And then plug that in. So g of 5/2 equals, oh geez. This also gets pretty ugly. I'm going to use a calculator for this just to help myself out a little bit. So that's to the 6th power times 4. That first part is going to be this, and then minus, so it's 5/2 to the 5th times 12. Okay. And that's going to be a negative this. Okay. number 7 now. Oh, this is not my favorite. I don't like this one very much. This one's a difficult derivative to take, or not so much difficult, but it's difficult to simplify, I suppose, to get it how they want it here. For this, we're going to have to use the product rule and the chain rule, because we've got a little chain in here, we've got a product here. So remember, product rule is this here, our first term times the derivative of our second term, plus the derivative of our first term times our second term. So let's start off. I know I could do this backwards. I'm going to do the derivative of my first term is 1 times my second term. So I just get this here plus my first term times the derivative of my second. And now I need to use some chain rule. So remember, this is also same as to the 1/2 power. So take the derivative of that. So it's going to be 1/2 m to the negative 1/2 times the derivative right inside. Okay. Which I could also rewrite as, remember, this negative means it can go on the bottom here. So it's going to be that. And it's also square root, right? So that turns into a negative 2x over 2 square root m. 2 cancels out. You get negative x over m. So it's going to be negative x. And m in this case is this inside. Oh, over square root, sorry. Over the square root. Okay. And I'm going to start off by just multiplying that together. So it's going to be this. Well, I suppose instead of adding a negative, I could just be subtracting. So minus. Okay. And now, obviously, that's our derivative, but that is nowhere near in these terms. So let's try first giving these a common denominator so we can put those together. So I'm going to multiply by this. Multiply it both sides by that. Not both sides, but top and bottom. So it's going to be 25 minus x squared, 25 minus x squared. And I'm going to do the same thing over here. No, I'm not. No. I don't need to do that to this side. I only need to do it to this side. Because this already has that denominator, right? So if I multiply this times this, that's going to undo the square root, so I get 25 minus x squared, and then minus x squared there. And now they've both got a denominator of this. Combine like terms, I get 25 minus 2x squared over a square root of that, and I'm going to rewrite that as a power. And now we've got a derivative in terms that they like there. So our a is going to be that 25, our b is going to be a negative 2, and our c is going to be that 1/2 power. Now we have to take the derivative of this, which is where it gets especially ugly. So now we need to apply our quotient rule, which remember, low d high minus high d low over low low. So I'm going to get this times the derivative of my high term, which is going to be negative 4x, minus my high term times the derivative of my low term. And my low term is the same as this, isn't it? It's that square root there. And I know the derivative of that is that bit, so it's going to be negative x over that square root. Okay. And I'm actually, instead of the square root, I'm going to keep it as that power, just for consistency's sake. All over low, low. So it's this square root squared. So, but I'm just going to write it like this so that we can see it a little bit more clearly, because this was hard to recognize. I see that I've got this in both pieces, but this one's a negative 1/2, right? And actually, to make that a little bit clearer, I'm going to go ahead and write that. That's a negative x times... I didn't give myself enough space. To the negative 1/2, if I want to write it like that. So how would I factor this out of there? Well, I know that when we're multiplying two exponents with the same base, we just add the exponents. So in order to get this, I know I could have this times this, right? Because adding these together would get me that same exponent. So I'm going to factor this part out of here and be left with this over here. And that may feel like it's not useful, but I promise it is. Which means I can factor out this from the whole thing. So I'm going to go ahead and do that. Not negative, sorry, just the positive version. And now I get that negative 4x minus 25 minus 2x squared, which was that top there. And now factoring that up, so I'm getting a negative x times this part here, all over the low, right? And now I can see pretty clearly that that cancels. Okay? And now we're getting somewhere. I'm going to start rewriting this as, maybe not. No, yeah, I'm going to rewrite that as this now, because that's, right, that negative 1 just means it's on the wrong side of the fraction. And so this is all going to become, let's keep going, 4x minus, and now I can just multiply this into that numerator there. So it's going to be minus a negative 25x plus 2x cubed over 25 minus x squared all over this square root still, 25 minus x squared. Actually, yeah, I'll stop putting it as a square root. Okay. And this, again, kind of feels like we're going nowhere, but I promise you we're almost there. So now, see, I've got this fraction up here, and I'm subtracting this. So I want these to have a common denominator. So I'm going to multiply this by this, top and bottom, so that I can put that in that numerator there. So it's going to be negative 4x times 25, so it's going to be negative 100x plus 4x cubed. And that's now in this same numerator. So minus a negative 25, so plus 25x minus the 2x cubed, because I have to distribute that negative right here, and that's all over this still. I'm going to combine any like terms here, so that's going to be a 75x plus a 2x cubed. And obviously this is to the 1. And so now I can kind of combine these, because this is the same thing as like all of this times 1 over this. And when we multiply by fractions, we just multiply straight across. So I'm going to add these together now because they're being multiplied. So it's going to be a 1 1/2 power, or a 3/2 power. So, I figured that out already. It's going to be a negative 75x plus a 2x cubed all over, combine these to the 3/2. And now it's finally in terms that they like, although it's all the way over there. So I'm going to just rewrite it real close. So that's going to be, I'm just going to put the 2x cubed in front, minus 75x over, okay. And now comparing that to this, we see D is 2, E is the negative 75, and F is the 3/2. Now we're not done with this question, as much as I'm sure we'd like to be. I'm going to erase this and just rewrite those derivatives so that we've got a nice kind of clean blank canvas to work on for the rest of this question. Oh, that didn't fully work, but that's okay. All right, so that first derivative is this here. Okay, and our second derivative was this. Okay. Now, in order to find our relative extreme points and its inflection points, we set these equal to 0. So this equals 0 whenever our numerator equals 0, although we know for a fact that any x greater than 5 is out of our domain, right? Because that would require us to have a negative in our square root. So our domain, x has to be both greater than or equal, no, it has to be greater than 5. Oh, no, sorry, less than 5, and greater than negative 5, right? Because negative 6 would be, squared would be a 36 in here, so it'd be 25 minus 36. I'd get a square root of negative 11. That doesn't work. So it has to be in there. So now keeping that in mind, because remember our critical points are only within our domain. Keeping that in mind, now it's whenever my numerator equals 0. So it's going to be 2x squared equals 25, x squared equals 25 halves, x equals plus or minus square root of 25 over 2, which is plus or minus 5 over the square root of 2, which is a little less than 5 because square root of 2 is a little more than 1. Now this equals 0 at, well, 2x cubed minus 75x is the same as this. So at x equals 0 for 1. And then 2x squared equals 75, x squared equals 75 halves, x equals plus or minus square root of 75 halves. It's going to be greater than the square root of 25 halves. Okay. And now we've got our intervals. We've got negative infinity, negative square root of 75 halves, up to then up to 0. Okay. And there. I know that square root of 75 halves is going to be less, this is going to be greater than 8 over square root of half, square root of 2. That's going to be less than that, so that helps me, which is less than or greater than 8 and less than 9. So And remember that this is that's less than 5. Greater than what exactly? Well, I know it's at least greater than 2, so I'll use that for reference. So now, use our second derivative test, use a -9 here, use a -5 here, -1, +1, +5, +9. Okay. Let's go ahead and, oopsie daisy. Not what I meant to do. And it won't let me undo it. My favorite. Okay. Okay, so if I plug in a -9 to, let's take a look at this part, because that's how I rewrote that bit there. The bottom doesn't matter. That's always going to be positive because of the square root. Oh, no, -9 is outside of our domain, actually. So this doesn't matter, and this doesn't matter. Well, yeah, this doesn't matter, and this doesn't matter, and this doesn't matter. I don't know how I missed that. I made such a big deal about the domain. So we just have to look at this bit here. So if I plug in a -1, makes it nice and easy. It's going to be a -2, -2 minus -75, greater than 0, up, 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 up. Wait, well, hold on. Hold on. So I know this doesn't matter. Aha. The endpoints of this are not the next inflection point, but instead -5. Okay, that makes more sense because I definitely need those intervals. Okay, and it can go up to there. Okay, so instead of -5, well, now I have to check if it's less than 4, if I have to go somewhere in there. Okay, it is less than 4. So I can use a -4 and a 4 in there. Okay. And that's going to be -4 to the third is, I think, a -64. -64 times 2 is 128. Minus 75 times -4. 75 times 2 is 150. So it's already going to be bigger. So it's going to be greater than 0. Okay. Plug in a -1, and I've got a -2 plus 75 greater than 0. Shows me I've got a minimum here. Plug in a 1, I've got a 2 minus 75. That's less than 0. Plug in a 4. It's going to be all the exact opposite, right? So it's going to be less than 0. Which means I've got a maximum there. So relative minimum is at this point, and there's no others. There's also only one maximum, and the relative maximum is at the positive one. This graph has inflection points at 0. And it's just the graph. We can't include the other inflection points since that is outside of the domain. And it is concave downward from here. So from 0 up to 5. Okay, we've got 2 questions left. Almost home free. Okay. Just going to erase that for space. It says the concentration of something after t seconds is given by y equals this for t is greater than or equal to 0. We want to find when the concentration is at its maximum. So we first take that derivative. So I know that's 3. I know the derivative of e to the power of anything is just itself times the derivative of that power. So the derivative of that's going to be negative 12 e to the negative 12t. And then same thing here, so it's going to be minus a negative, so plus 14 e to the negative 14t. And now we figure out where that is equal to 0. And that's a little bit of the tricky bit. So set that equal to 0. Now we see that 3 doesn't matter, so we just get this here. And let's see. So I think I might add this. I don't super remember this, so we'll see how well I can remember this. This one was a tough one, I felt like. Okay. So, okay, good. Yeah, and I can divide by 12. So now I've got 14 divided by 12, which is the same as 7 over 6. E to the negative 14t equals e to the negative 12t. Now I can divide both sides by this. And of course, when we're dividing same base, we subtract the exponents. So negative 12t minus a negative 14t is going to be 2t. So I get 7/6 equals e to the 2t. And now I can use my natural log. So natural log of 7/6 equals 2t. T equals 2 natural log 7/6. Okay. So I'm gonna erase all this bit and just kind of move that up there where it's a little out of the way. So now we've got our interval. We've got negative infinity up to this point. Okay, and then we've got this point up to infinity. Well, we want to make sure that this is a point of maximum. So let's see here. What is something bigger than this? Okay. I might cheat a little and use my calculator for this point because I'm fully blanking on how natural logs work. Okay, so that is about here. So we can plug in a 0 and a 1 to that derivative to see if it's increasing and decreasing on each interval. If I plug in a 0 for that first bit into my derivative, that's going to get 0 up here, so it's just going to be negative 12 plus 14 equals 2, so that is positive, it is increasing there, going up, up, up. If I plug in a 1, I'm going to get negative 12 times e to the negative 12th plus 14 times e to the negative 14th, which is then negative 12 over this, which is, this certainly seems bigger, but I'm not confident, so I'm gonna use a calculator for this bit. Okay, yeah, and this is negative, so it is decreasing, which means that this point is at its maximum, and that is our t value. So t equals 2 times the natural log of 7/6 seconds. Okay, one last question left. This one's a little bit of a tricky one, but it's not too bad once you understand it. So it says, a cylinder is inscribed in a sphere with a radius 12. Find the height h of the cylinder with the maximum possible volume. Volume. Maximum possible volume. Okay, so we've got a sphere. Wow, that's ugly circles. Okay. Then we've got some cylinder inscribed in it. Okay, and that obviously it's inscribed, so these points are going to be along the edge. Okay, so I know it's got a radius. I can use a capital R for that, of 12. Could also do it right there to that corner, right? Because anywhere on here, that radius is going to be 12, because that's how circles and spheres work. So what ends up happening is then I've got the radius r of the cylinder that only goes up to here, and I form this little triangle with the radius of the cylinder, the radius of the circle, and half the height of the cylinder. And that helps me already. So let's just figure out, let's see, what is the volume for a cone? I believe it is it pi r squared h, or is it 2 pi r squared h? That is the question. Let me just make sure I have that right before I start doing it. Okay, yes, it's what I have written. It is pi r squared times the height. Okay, you want to find the maximum possible volume, so we're going to take the derivative of that, but let's first deal with our little triangle here. And since we want to find the height h of the cylinder with the maximum possible volume, I'm going to figure out what r is in terms of h based on this here. So I know based on Pythagorean theorem that this squared plus this squared equals this squared. So 144 equals r squared plus h squared over 4. So now I'm going to figure out what r is. So I'm going to subtract that from both sides. So r squared equals 144 minus h squared over 4. So then, oh, I could take the square root of that, but we've already got an r squared, so I can just plug this in as is. So I'm going to plug that in for my r. So it's going to be pi times r squared is this, times h. And I'm going to distribute the h because that makes it a little easier. So it's going to be pi times 144h minus h cubed over 4. And now I can take the derivative of this with respect to h and not have anything weird going on. So if I take the derivative now, so dv dh, it's going to be pi, that's going to be 144 minus 3h squared over 4. And remember, this is just power rule in there. And this is a constant coefficient, so I can just keep it out there. So this is our derivative now, and I want to know when this equals 0 so I can find my critical points. Well, 144 minus 3h squared over 4 equals 0. Well, that's going to be 3h squared over 4 equals 144, right? Because I'm just going to add this to both sides. I just kind of flipped it how I'm looking at it. Multiply by 4, I get 3h squared equals, oh, that's going to be 400. 60, 16, 576, and so h squared equals 576 divided by 3. H equals plus or minus the square root of 576 divided by 3, except it's only plus because it doesn't make sense for a cylinder to have negative height, right? So this is our answer. So now we just have to make sure that that is the maximum. So let's take our interval, and we've got this here. We just make sure that it is increasing and then decreasing. So let's take our derivative here. We're just going to plug in, oh, what is a number bigger than that? How big is that number? Let's see, 576 divided by 3. Okay, so this is about 13.85-ish. So let's plug in a negative 14 maybe. Yeah, we'll plug in a negative 14. So plugging in negative 14, I've got pi times 144 minus, oh, what is 14 times 14? Let's see, 16, 4, 5, 4, 196. So it's 3 times 196. And then divided by 4. So I know 196 divided by 4. Can I do that? Divided by 4 is 49. So it's going to be 3 times 49, which is 120 plus 27, 147, which is negative, which makes it decreasing. That doesn't seem right. I feel like I messed up somewhere. I'm going to use a calculator instead of trying to do all that like that. No, it's negative and decreasing. Well, that's no good, because that doesn't make sense. That means that it's decreasing the whole way too, doesn't it? I feel like I've made an error, but I don't know where I've made an error. You are supposed to, so this is the volume, right? You're supposed to do this and plug that back in, and then take the derivative. Might just be that the radius I came up with isn't one that works well for this, but it doesn't make sense because it totally should. Frustrating. Not sure where I went wrong here. Well, let's try a different radius, actually. Let's try, I'm going to leave my picture, actually. I'm going to leave there. I'm going to take away everything else, though. Let's try a different radius and see if I can do it right. Let's say the radius is 6. Okay. So r equals 6. So now it's going to be 36 equals r plus this. Oh, r squared, sorry. R squared equals 36 minus this. Our volume equals that, which equals that, which equals, whoops, not pi. Oh, did not undo the right things. Which equals that, as we distribute the h, and then take that derivative. I get pi times 36 minus 3h squared over 4. And that's going to equal 0. So 36 minus h squared over 4 equals 0. 36 equals 3h squared over 4. 36 times 4 is 120 plus 24. 144 equals 3h squared. So 144 divided by 3 equals h squared. H equals the square root of 144 divided by 3. And let's see about what that looks like. That's about 6.928. So let's try our intervals again. You know what? I definitely didn't need to try a -14. Because we can't actually go from negative infinity. We're going from at smallest 0. That might have been where I messed up actually. So let's try a 1 and then a 7. If I plug in a 1, that's going to be 36 minus 3/4, which is positive, increasing, good. 36, and if I plug in a 7, it's going to be 36 minus 3 times 49 over 4, which 3 times 49 divided by 4 is, it's going to be negative 3/4, which is negative, so it's decreasing, which this is a maximum. Yeah, so I think the issue is that I was just plugging in a negative value where that didn't make sense for the domain. But so now with this new radius of 6, it's going to be, the height is this here. And I'm assuming the height for the other one was also probably correct. But yeah, that is the last question. And we've done a good bit. I hope that most, if not all of this made sense, and I hope that this video was helpful. Yeah, thank you for watching.